Hi there. This is a TI Launchpad F280049C C2000 real-time MCU from Texas Instruments. This microcontroller has a fine-grained memory partitioning controlled by a linker script. That linker script is this one. So every time you change the size of your heap and stack, you always need to adjust the linker script accordingly. I'm using the Code Composer Studio, and I installed the Parasoft plugin in the IDE. We are going to analyze this code statically and dynamically. If we go through properties, we can see that the compiler of this project have these options set by the IDE as well as the linker. And then here we can see the heap and the stack allocation. The default heap and stack is much smaller. I increase it to this bigger value to accommodate the instrumentation that is going to take place when we do unit testing of this project. After I increase it to this volume, I additionally adjust the linker script. So this linker script now and the memory heap and stack is enough for instrumentation. Before we can analyze the code, make sure that the code should build without errors. Project, build and clean. And through the process of building a project will give us an opportunity to look what compilers use, CL2000. Now going back to properties, these are the build options of the project. To analyze the code in C and C++, there are a lot of things that you need to be familiar with, can be aware. Can be aware what the hardware is, its nuances. Should be aware of the toolchain used, at least. And then an instrumented build of Parasoft settings is here. The lowest important setting of all is the correct match-chain compatible compiler family. Here it is set to EMS 320 C2000 compiler. This is from Parasoft. Aside from this, we drop down. Other families are supported from Wind River, Renaissance QNX, IR, Green Hills are Microsoft Visual Studio, GNU, and so on. You will notice that these toolchain are the type of toolchain used in safety critical applications. So these are C and C++ programming that runs on airplanes, automotives, industrial settings, where safety critical is a factor. After setting the compiler family, AI, so Parasoft instrumentation build also have its own compiler options, where you can add more. Here I added 2 object files. Here. Manually, I added this manually. This does not come automatic, by the way. I added it. And then this checkbox, let me try to explain it. This one is checked, synchronized with project settings. It means that the Parasoft instrumentation build inherits most of the default compilation options in the project. In certain situations where the checking of this checkbox gives a problem rather than it solves, you need to uncheck this. And as a consequence, because it does not inherit anymore from the project build options here, then if the checkbox is unchecked, then you will need to meticulously supply here in the compiler options additional flags that goes to the instrumentation build. Usually, these are flags that came from here, so you need to pick. Most of these are the CPU flags, and then populate it here. Right now, because this is checked, we don't need to do that. This plugin has a good support. There are these two object files which I added here. Corresponds to these two assembly files here, which do not participate in the C build and linking. Does not participate in the C build, but only in the linking. So the object files of the assembly join the firmware during link time. So because Parasoft build does not know that, that's why we have to supply it there. If you will not put it there, then you will see missing symbols, like functions that are not there, which will trace back to this assembly object file if you do a grep. So you will find it, and then you will have to put these object files there manually. So usually these are startup codes, like startup.s in other microcontroller board. Now that we have the setting set in the configuration, it's time to do static analysis. If I select this parent node here, I would be analyzing every C code of this project, which will take a while to complete. Or I can just select one C file and analyze this instead for a faster result. Select sensor C. Static analysis. And then I will select automotive and Mesra C2025. So you saw that there are a lot of coding guidelines in different domains. I will select Mesra here. So static analysis does not require compilation. Just statically analyzing the code in Parasoft supports three types of static analysis: pattern, flow, and matrix. This one, Mesra, is a combination of pattern. It's a combination of pattern and flow. And it's finished. You can see the results in the IDE here. If you click it here, you will lead to the line of the code where the relation occurred. Now the function should not be used. Or you can generate a report here. And publish the results on HTML. The ID that you see here, actual ID, identifier of the Mesra rule from the PDF of the Mesra itself. So the Mesra coding guidelines is being automated in a Parasoft static analysis. So again, going back to this configuration, static analysis in the matrix. So the matrix includes measurements of complexity like inheritance level, can go to documentation like this one. Very deeply inherited C++ class, it can be measured. Or number of methods in a function, like this one, a function with several. So all of this belongs to the matrix. The other one is flow analysis, which is a method to detect memory leaks, non-up without corresponding free and other stuff belonging to pro analysis like division by zero and so on. And the third one is we have pattern, okay? Like as you saw in the measure, mostly. So these are a quick summary of static analysis. Now I'll proceed to dynamic analysis, also known as unit testing, in order to get good coverage. Right now, we do not have these cases. We have our firmware code, but no test cases yet. But even at that, we can instrument the firmware as it is right now, flash it to the target hardware, and gather good coverage. And that is what you call as application monitoring. So to do that, go here, and Texas Instrument, select application with memory monitoring. So what it does is it builds your firmware in an instrumented way, flash it to the board, and returns test results data back where code coverage is computed. So the blinky here enters into the main loop and executes this. You see it's blinking now. After execution, it returns back this results data. And here it is. So application monitoring nails your firmware without any test cases and gives you coverage data. By default, test configurations in Parasoft has line coverage by default. There are other types of coverage, I think 8 or 9 types. MCDC function, I will show you later. But you will see that line 71 is not covered. This is the time to create unit testing that will cover line 71. To do that, add a unit test in the translation unit. First, I will create a test suite. A test suite is an empty test case. And then I will add a test case for blink. But in this test case, I will simulate 1,000,001 to shift that uncovered area. But before running this case, observe that in application monitoring, you enter into the main where initialization call sequence took place to initialize the microcontroller peripheral. In unit testing flow, it does not enter into your application main. It enters into a different main synthesized by Parasoft called the harness. And then that harness directly calls the test cases. So a unit test in Parasoft could not by default initialize the microcontroller. So I need to copy this initialization calls. And in the test suite, where my test cases is running, where I simulate 1,000,001, there is a placeholder where we can initialize the microcontroller peripherals. Here. So the test suite setup and the test suite Here down, our test suite level initialization. And this one is this case level initialization. These are common in testing frameworks. And once the test suite is setup is run, initializing the microcontroller, the Blink is executed, and because the Blink function above uses GPIO, there's really a need to initialize the microcontroller here. Otherwise, if what you're testing is pure C code that does not use a peripheral of the microcontroller, then there's no need to initialize. Because what you're testing is a C code. In fact, what you need to initialize are what this case is using. Here, I initialize everything. Now that we have the needed initialization in the test suite setup, let me delete this covers results and let me run again. First, I will run application monitoring. So it will run your firmware in cemented version. So it's always a good sign to check the motherboard to see some interaction. So the communication used here is semi-hosting. So it takes it's a little bit slower. Other types of communication is UART serial or TCP/IP. So it's running now. So as usual, we cannot cover this, but because we have a test case, I will run again the test case. So it is creating another firmware and flashing it again. So it's a different firmware, flashing it now. This time it is entering into a different main, into the main of the test suite, which we have our initializer, and then it makes a call to our test case. And there we have it. So together with application monitoring and unit testing, we achieve 100% coverage of the Blink function. We are able to hit line 71 using our test case, which otherwise could not be hit with application monitoring alone. Now, let's take a look at sensor.c here. This is a pure C code. It does not interact with the peripheral of the microcontroller. I can right-click into this code and then auto-generate test cases directly. So in one click, test cases have been generated. Because the translation unit being tested does not interact with peripherals, there's no need to put initialization in the setup of this test suite here. I can right-click also here. Before I click here the parent node, but I can also run and the test explorer area. I can click this test case or I can click the test suite. I'll just click the test suite and then run unit test. So sensor.c is a pure C code and no initialization of the microcontroller is needed. Just wait for it to complete. and it's done. So again, by default, we have line coverage. So I noticed that line 157 and 156 and 157 never hit. And this is already a unit test. Okay. And the return of red sensor status failed should bring me to this line. If I scroll up, red sensor only returns these two values. But I needed to make it return status failed. Parasoft has feature called stubbing. We can make red sensor return status failed without changing the implementation of red sensor through Parasoft stubbing. To do that, go to Parasoft, view, stubs. Locate the red sensor. Here. As here, right-click, create user stub. I see stub, let's see. So copy this part here. Go to the test suite at the topmost. And make this stop of red sensor with current status failed. Right now, this is still not operational. Nobody is calling this stop because it has not been registered yet. In order for this stub to be called, it needs to be registered. The ID is register call here. Hey, let me curious. So, the red sensor is being called by main loop in a call chain. And we have one case for main loop here, and that's here. I will duplicate this. And in the duplicated copy is where I will register the stub. In the first main loop, it will call to the original read sensor. In the second copy, because we registered it here, it will call to the stop version, which is here, and we get the needed status failed result, which will hit this line. Okay? And now that it's there, let me try to run it. So the stopping feature allowed us to have a red sensor that returns status field without modifying the implementation of red sensor. So by default, this is line coverage. Now, how do I get additional coverage? To do that, you have to duplicate this configuration. I duplicated it here in user define. This one. So to duplicate, you just need to go to the rule configuration and right click and duplicate. I already did that here. In the duplicated copy, just check coverage file, but you have to be careful. More coverage means more strain on the resource we keep are stacked, so the memory may not fit. If your memory is not enough, then you may have to run it individually. Now, let's click, and then delete this and run again. This is a user define, so you have to go to user define and run. So this time, we're running the same test but with more coverage enabled through the checking of the checkbox. And there we have it. So you can see here, we have line, statement, function, decision, and MCDC. Let's try to generate a report. So we will see columns of different types of coverage. Line coverage, statement coverage, function coverage, decision coverage, and MCDC. So remember, all of this depends on the capacity of your microcontroller. If the capacity is not enough, you will see an error like this that fit in memory or just weird behavior. So observe accordingly. So today, I have demonstrated Parasoft code analysis tool in Texas Instruments for a C2000 microcontroller using Code Composer Studio.